Everyone is super silent.
Okay, so I would like to welcome everybody to this second edition of Industrial IoT today. In this session, we're going to focus on digital twins for smart manufacturing. Particularly, we're going to try and decipher how it works on a practical basis. And to help us do that, I've invited an amazing panel of experts to share their insights on the topic. So I'll ask our panelists to introduce themselves. You can go ahead, Dana.
All right. Hello, everyone. I'm Dana Kawaz. I'm the CEO and co-founder of Thinkly. My background has been, I've been a digital executive for 18 years, focusing on digital strategy and roadmaps, technology implementation, and organizational performance. And at Thinkly, we're a progressive digital business consultancy, and we with technology services specialize in building digital twin of organization. So we are really focused on hyper automation strategies and technologies, augmenting human intelligence with artificial intelligence, optimizing business operations, building resilience in digital operations, and really making sure we're increasing digital technology adoption, the digital twin adoption, and upskilling people while we're doing this. So this is the focus. I'm also a co-chair at the Digital Twin Consortium for the Business Maturity Working Group.
Awesome. Ajit?
Oh, hello, everybody, and thank you for inviting me, Kudzai. So great to be in Johannesburg online. And one of the interesting announcements is I will be a professor at the Johannesburg Business School next year. And I think very much, hopefully, at some point, I will be there as well. So I'm most of my work is based at Oxford University. And what we are looking at is the idea of digital twins from a more broader perspective, meaning looking at the model-based design perspective. And for us, this means that it's not just the idea of the twin, but also taking it right up to the manufacturing process, right from the CAD designs to sort of additive manufacturing, right up to AR and VR with that as well. So I have been mostly involved from a teaching perspective at Oxford, looking at a full stack AI course, which means a very heavy emphasis on algorithms. And on the professional side, I have a consultancy called Fine Labs, which deals with the same thing. I am also the chief AI officer for a German company called Digity, which is also involved in my role there is involved around Bayesian algorithms and stuff like that. So this is a basic introduction of me. Yeah, thanks.
Okay, Rob?
Hey, Rob Tiffany. So I'm the VP and head of IoT strategy at Ericsson. So we make cellular technology like 5G. And I'm also working on some internal entrepreneurial products right now, helping out with agriculture these days. Most of my background, I used to be a total startup junkie, then spent most of my career at Microsoft. One of the last things I got to do there was build Azure IoT. And so that was fun building that system in the cloud around the world. And then I think I got my first taste of digital twins back in 2016 when I was recruited into Hitachi. And so I designed an industrial IoT platform there called Lumada, and digital twins or asset avatars were at the core of that system. And so that's kind of where I got my start. Happy to be here with all you smart people.
Awesome. Yeah, and Nicholas.
Good stuff. Yeah, it's a tough act to follow, to be honest. Okay, my name is Nicholas Wern. I am here in Sweden, and I got screaming kids in the background, so we'll see how this is going to go. My background is in innovation and strategy. Studied some of the best universities here in Europe. It's also in Asia, in South Korea and Switzerland, and also here in Sweden. Been in the smart building space for the last, I would say, 7 to 8 years. So that's how I started. Learning about IoT, edge gateways, innovation and strategy, and that it's not so much about technology, but a lot about people, what Dana was saying as well. And then went into more construction the last 3 years. And that's how I realized, if you combine building information models, CAD models, and IoT, you sort of get digital twins. And that has led to being co-chair being co-chair of manufacturing digital twins for the Digital Twin Consortium, working with self-driving cars, self-driving buildings, also in digital twins in healthcare, with AI strategies at large, national digital twins, European digital twins, and having my podcast, also interviewing global leaders in this space, and advising a lot of companies in these areas, including telcos, universities, and in a lot of research think tanks across sort of a lot of domains. So that's sort of like, I think the digital twins can actually, help solve all the problems in the world if you do it right, with the right ingredients, which are of course people, AI, systems, and absorbing standards, so that you can run this physics-based modeling on top of actor-based networks and multi-agent systems. So I'm super happy to be here, and thanks so much for inviting me. Thank you so much.
Okay, great stuff. It's great to have you all here. Okay, so before we proceed, I would like to thank our sponsors who made this event possible, and that's Hive MQ, who are providers of an enterprise-grade cloud and edge-based MQTT broker, and also Opto22, who are manufacturers of reliable industrial controllers for automation and IIoT applications.
Nice.
Okay, so to our audience, we're going to be taking some questions at the end of this session. So in the meantime, could you please let us know where you're joining us from in the chat section below? Okay, so to get us started, Rob, could you maybe set the stage for us here by giving us an introduction of what is a digital twin and where does the concept originate from?
We'll tell you if we think it's wrong, Rob, so don't worry about it.
Yeah, thank you for that. I'm sure whatever I say is going to be wrong.
No, everything is right.
You know what? You'll never hear me talking about AI with digital twins because I believe people should know their limitations, and so I'm no AI guy. But I've certainly been a builder of digital twin platforms that other people can run them on, and so I know kind of how they work. When I do the sessions on digital twins and kind of give background, I'm so corny. I always do the same thing. I always talk about, did everybody see the movie Apollo 13? When Tom Hanks and all those guys are trapped in space, and then they had to try to figure out how to get home because things went wrong with the spaceship, and they're trying to get back from the moon, and all kinds of problems are happening. And it's a good example of a physical twin, because while they are trying to work the problem in space, there is a replica of their spacecraft in Houston at NASA. And so down there, you've got Gary Sinise, and they're trying to work the problem. And this is a good example of troubleshooting. And this whole concept and what happened led NASA to realize, oh my gosh, we need to create high fidelity digital models and versions of these complicated spacecraft to be able to do this kind of troubleshooting, because we can't always have a huge, expensive, physical version of the real thing. Obviously things had gone too well for them for too long, but the reality is you never know, and you might have to troubleshoot. And so that's kind of that first seed or germ of an idea of, gosh, maybe we should have digital versions of this stuff so we can troubleshoot it when we're trying to get a square thing to go into a round hole to get CO2 out of the atmosphere. If you kind of leap forward, I've seen lots of people have seen digital modeling happening. A lot of people, just the quick, dirty answer to what's a digital twin. It's kind of like a digital version of a physical object or process. And of course, people have gone from saying that to saying it's everything these days. It's getting kind of crazy. I remember personally in the 90s spending time at Boeing, because I'm here in the Seattle area, and I remember when they went from designing aircraft on paper, blueprint, like an architect, to using this digital system called CATIA from Dassault Systems. And that was a big thing for them to digitally design an aircraft. It was a huge leap. And that was the first glimpse I had of the idea of digitally modeling something. If you move a little bit closer in time, you had this guy, Dr. Michael Greaves, who kind of came out and said, you know what? He called this thing a double ganger, kind of like a doppelganger. And he's one of the people kind of credited with really kind of kicking off, in more recent times, late 90s and then early 2000, with the idea of a digital twin, and he really started writing about it. He was all about product lifecycle management, that whole PLM space, which I know a lot of us, when you think of PLM, you think of like PTC and ThingWorks, right? Which ThingWorks was one of the original industrial IoT platforms that had digital twins at its core. And so, and famously, which is relevant to here since we're talking about industrial stuff, Dr. Greaves said that Industry 4.0 is only possible with digital twins. So it's probably something everybody in our audience, if you care about this stuff, should probably learn about. I'll leave it to you smarter people now to contradict me.
I think it makes sense, right? It's the combining the IoT stuff as in real-time data. So I think like what you said with the creating the digital aircraft, but then once it's up in the air, or combining that with either real-time data at various fidelity or frequency, every 10 minutes, 1 second, etc., that's supposedly some kind of digital twin, I guess. But
you gotta have that
great
data.
Yeah, great stuff.
Yeah.
Great stuff, Rob. Yeah.
Okay, yeah, that's an interesting backstory. Now, Dana, as Rob has already alluded to, the term digital twins gets loosely used, to refer to quite a lot of things, So what would you say are the key characteristics that are required for something to be called a digital twin?
Yeah. Absolutely. So this is, again, a digital twin, a term that is being used. It's a buzzword too. And it confuses people because they look at simulation and they consider them digital twin. Some people consider BIM digital twin. So like really, what does that look like? So regardless of what a digital twin is, an enterprise software. It's implemented, a virtual representation of an IoT connected with entity used to provide situational awareness, help improve business decisions, and the business outcome. So regardless of what digital twin you're using, what type you're using, or what use case you're using, there are certain building blocks that really exist with every digital twin, and one of them would be the data sources that you're collecting that is coming from different, not only the IoT devices, but also you have the applications and you have the process and the people. So you're gathering all that information, putting them, connecting things in digital thread, where there's that flow of information. You're translating the data into knowledge, so you can actually move it forward in the virtual scheme. And that knowledge comes from people, system, existing systems, IoT. And then there is also, we do have the twinning rate. Like, what are we talking about from a frequency perspective? Is it like a real time or near real time? And what would that look like to connect the physical with the virtual world? And the data is the one that flows in between all of that. But also there's another thing when we talk about digital twins, which is systems of systems, right? Like, it's not one replica of an entity. We're really talking about that kind of connection and systems of systems. It's dynamic, autonomous, there's collaboration to achieve really those business outcomes that we're looking for. One key part of it is to the analytical models that we build on in digital twin that really kind of provide you with what if scenarios, what is next. So kind of those predictions that would help with decision making. So those are really important characteristic of digital twin, regardless of the software you're using or where you're using it. And then another one is the governance, right? The fidelity part of it is like how all this information is working, who owns the data, how we're going to govern the process between the virtual and the physical entities. So all of this, the simulation, the modeling part, that is also very important part of a characteristic of a digital twin. So I'll leave it open. I'm sure again, Rob, smart people around here have more to add to that.
Okay, yeah. Well, anyone wants to add to that?
Yeah, sure. I'll say a few things. I think that this is a very interesting insight from both Rob and Dana, because I think the Rob's example of the NASA side, I think it's such a great example to kind of open the stage with that. I think the way we approach the problem, and the reason I like digital twins, because I started looking at it from IoT and algorithmic point of view, and I'm probably stronger on the algorithmic point of view. I'm not more of a hardware person. So I'm less of a hardware person, this is what I mean. But we found digital twins easier to explain to people, yes, because it relates to a physical problem which they have. It's very hard to explain to people what is a sensor, what is an algorithm, and what does it do. What's easier to sort of encapsulate everything together. And to take the example of the building systems, we said, I mean, we can talk about sort of a handover phase, yes, in the building architecture situation, which is a kind of replacement for your documentation. But the process is far more richer, yes, because it's now combining the data, the algorithms, the what ifs, everything into one piece of software. And again, the example for Katya was interesting because I think this also, I didn't know that that was what was used to design the Boeing, this thing. But I think that these things, as Rob has said, and as we have said, they've been around for a long time and they tend to morph into something different. Yes. And I think this is another such incarnation. And the way we looked at it at Oxford was to think about like a methodology to try and solve this problem for people, because this, I think, is the key missing link there. There are two missing pieces here. The first one is the methodology, means given a problem, how do you kind of, what's the kind of a template which I can say that, okay, this is what, these are the things I should look out for, and what would they mean? Many of them were said by Dana already in her fairly detailed talk. And the second thing from my perspective is to simplify, to make it like a low code version, to make it like a say that I give a problem, I get quite a quick outcome to something, as opposed to buy an expensive piece of software and then work through it, and then if it shows up a result long term later. These are sort of my kind of slants on the same problem, but I think we're all talking about the same thing, and it's nice to see that, because that kind of validates the process as well.
So just want to add something. Ajit, you touched base on a really good point here, and that's something we do as part of what we do at Thinkly in terms of helping businesses kind of build their roadmap for digital twin, because it's a journey.
Yeah.
And really you got to begin with the end in mind, regardless like what like you have to know what are you designing it for, like whether it's there's so many application and use cases you can use it. It involves monitoring, improving outcomes, cost efficiency, you know, like maintenance, process, people, the organization itself, operations. But if you don't really know what that end looks like, you gotta go backwards and then use digital twin for that. So it's always like, oh, we just want to create a replica of a physical asset and that's it. But really it does go beyond that from an organizational perspective.
Very true. Yeah, thanks.
Awesome. Now, well, clearly the digital twin is a combination of different technologies. I mean, even as you explained it, Ajit. So could you please outline for us the key technologies that enable digital twins?
Okay, sure. You're asking me, yes?
Yes.
Yeah. So sure, yes. I think that in my mind, first of all, digital twin, if you take away everything else, yes, what is remaining? The core is the data. Yes, so it's about data and then replicating a model of something using the data. Yes, so very much similar to, because if you want to duplicate the Apollo 13 on Earth, you must have something which not only has a point in time as historical data, but also point in time thing, because then this is how it looks like now, and that's what you do. So once you have the data, then you have the next stage is that you then build these things which you have the physical object and the logical object, and then you do the synchronization, and then you do the algorithmic side of it. Yes, so these are the different building blocks to creating this. Now, how to implement it? Actually, I think there could be a whole range of stuff. I mean, interestingly, I did not know Rob's background because I saw Rob as more or less Ericsson. So we also use a lot of the Microsoft things which he has built, he says, yes, the Azure IoT Edge, the Azure IoT Hub, and things like that. And the reason I say that is because when I look at the Microsoft digital twin implementation, it's pretty much using those technologies. Yes, so the technologies are pretty much what we already have. This is my point, that there isn't anything radically different that I see. Yes, there is a whole bunch of stuff around the simulation side, things which are coming up. Some of the things I talked about the AR, VR side, this is new as well. But the building blocks of the technology should be, in my mind, the same as we have used so far.
Okay, awesome. Now, Nicholas, we've defined the digital twins. We've talked about the technologies. So maybe just to make it clear for the audience, like for a manufacturing organization that is looking to get started with implementing a digital twin solution, what are the steps that they need to follow?
I think that's good, but if I mind, I can't, help myself. I just want to take it back a little bit and actually, okay. So for me, digital twins, I mean, it's amazing stuff. I'm writing stuff down here so I can remember it later. But it's for, this should be for people to understand, for systems to understand, of course, for AI to understand. There's also like my 3 core tenets, I guess. And also want to bring it back to what Rob said. And we talked a little about NASA here as well, about the physical twin. So again, like this is also from JPL, Jet Propulsion Laboratory, what they did in '95. So again, like they had this, planning of the space missions, and it took them 9 years. 9 years. It took them like 6 to 9 months at that time, at least. And what is it? Okay, we have to do this better and faster. Okay, so how should we go about it? And I think this is Dana's territory as well, more than mine at least. But I love the story because it just shows that the physical twin aspects are really exciting. I mean, exceedingly interesting just from the people aspect. So again, so what they did, they looked at the organization, okay, how many people are involved in the processes? Like 150, 200, whatever it was. They said, okay, let's cut this down to the most important people. Okay, and that was like 16 to 18 people. Okay, we need to give them the right information at the right time so they can make these decisions. Okay, so let's put them in a room, which has been problematic with COVID. So, thank God for digital twins. But back then it was physical twins. So you had people in the room, whiteboards all around, and you had the finance department, the operations, the analytics, all these kind of things in the same room. So they went from 9 months to 9 hours of solving the same problems, planning the space missions, right? So I think that is, again, like we could do that, understanding who the people are, what data they need, and put them in the same room. Because again, like if you change something over here, that changes something over there. They were lucky to be in the same room, but this is usually what takes the most time. Okay, so this is also an answer to your question for manufacturing organizations. So in the real life, you're competing with IT, OT, budgets, time cycles, political agendas. It is nothing to really about technology, to be honest. It's like in the proof of concepts, stuck in like pilot purgatory, never about the money. It's about the alignment of interest between the people. So like usually, I am a startup junkie still. I've been a management consultant as well, but I am a, startup junkie. And this is what I tell everyone, because usually founders think that, they don't get it. Yeah, they might get it, but 99% of, big organizations and manufacturing, whatever it is, they have processes, they have a culture, they have roles, they have people, and they have definitely systems, where you're trapping the data. That's usually on the OT side. But the IT, bang, 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 hey, we want to do more stuff. We want to get stuff connected because Rob has said so at some point. But then he comes like, okay, what are we going to do? How is this going to get done? So I think like going back to, again, if, digital twins are for people, AI, and intent to AI at least, and then, systems, get, the organizations involved, understand the alignment between OT, IT, the finance side, and, that's one of the most important things. If you don't have that alignment, an agreed business case, like a little bit across the pond, I think it's really, really difficult. Dana, maybe you want to chime in.
Yeah, absolutely. We look at digital. We always say this: digital twin is not an IT project. Like it is
absolutely not. Yeah, exactly. Yeah.
Like people come at it, it's flashy, it has all this, but it's not, because it does involve not only the data and that would be one of the challenges, which is kind of some of the key challenges, is like really the data and the backend data integration and the silos in their operations and who owns it and the process that you're using and the people who are using it. Like, so it's really beyond the technology itself. There's so many platforms that can do this, softwares, but if you got to have the organization ready and to adopt this technology and make decisions. Like one of the key things that this technology provide allows you to make better, faster, efficient decisions. Are you ready for that? Because now decisions are being made, like things are moving forward. So that's where the culture and the operational kind of the people's side of things starts kicking in as a challenge because they're not ready to adopt that or even change to really use the data to make better decisions.
I think just
yes, I'm going to.
Yeah, please.
Sorry.
No, just a quick comment. So it's like a little bit contradictory what Dana said before to some extent, that you have to know what you're going to do. I think, knowing where to start with, knowing which people should be involved, and then running this MVT approach as a minimal viable twins that shouldn't last more than weeks. Otherwise, you're going to get stuck in analysis paralysis forever, because right now there's so much twin washing going around, and there's so many digital twin platforms that claim they can do everything, to be honest. So get done fast, look at something, invite others to innovate, which I always say, and then try these things out, and but move faster. Otherwise 6 months is going to go like this if you're going to analyze 1% of the digital twin platforms out there, to be honest. Sorry, AJ, I just wanted to say
no. I was also going to add something which is again a different perspective, perhaps. So I think that I agree with what we're talking about, like the people and the data silos are the problem. But I guess my solution is perhaps more algorithmic, meaning it's perhaps going away from the sort of working with people, trying to get people in the room and getting together and stuff like that, because I find that in many ways that is that sort of paralysis situation with that. So my solution quite often is to work with more complex algorithms, which we try to do, and simulate more complex things where we try to overcome what I call as a cold start problem, meaning that the cold start problem, meaning people don't know what they want to articulate. What you need is something which shows them something and paints a vista of something, and then you give it to them, and then they start throwing things at it, and you use it to train the model, basically. So this is what I mean by the cold start problem. This has a more stronger algorithmic approach upfront. Some clients don't like that. Some clients don't understand that, but it is a chicken and egg problem. And as we are all saying that, because we've been here before. Yes. I mean, we've all been here before, where people get an idea of something and then they get in there and then they realize how hard it is, especially in the manufacturing domain and also some of the more regulatory domains, I guess, buildings. I mean, Nicholas talked about buildings as well. I think those areas where I think you have to, I mean, it's harder, especially from my experience, certainly in the manufacturing side with that. So this is how I tend to kind of view the problem. And this was just a different perspective on that. Yeah.
You know what? I need to get like Nicholas's Venmo so I can send him some management consulting money, because he just dropped some great management consulting buzzwords. Minimal viable twin.
Yes, I noticed that. Yes.
And twin washing.
Twin washing. Yes. See, I love it.
Isn't twin washing what's going on right now?
It is.
Isn't it hard?
On. Normally I'd be in Sweden every month if we were flying all the time, and we'd be hanging out, having a beer, and talking about twin washing.
Yeah.
This is great stuff. I love stirring the pot and stuff like this, because everybody I've talked to has a different idea of what a twin is.
Yeah, absolutely.
Okay.
You know what? Twin is software. I'm a developer. I'm an architect. No matter what I've done in my career, I still write code, and so I build the technologies that make twins possible. Are there different ways to do it? Absolutely. But at its core, a twin is a data structure. It starts with lots of people say it's data, it's algorithms, it's AI, blah, blah, blah. It's a twin is a structure, it's a model. And so when I'm creating a model, if I'm in Sweden driving around in my Volvo XC60, there's the model, my digital model of my XC60, right? It's this long. There's going to be static properties of it. It's how many meters long. How large is the gas tank? It's got 4 tires. Each tire has so many PSI. I guess you don't say PSI in Europe. Anyway, of air in it and stuff like that. And these are properties. Do you know how you create a digital twin? You define that in a database. Yeah. A database, there's different types. You can use relational, you can use graph, you can use object databases, NoSQL. But you're defining what the thing is with names, data types, and you create a structure. And then what happens?
But isn't this more of a PLM perspective? Looking at the physical object of that one. I mean, and then you can add risk, you can add all this stuff that it doesn't have, the physical aspects, from an organizational perspective as well. But I agree, but I disagree. I agree, but it's more than that. It's more than that.
There's so much to talk about. We could be here all day. But you start with the structure of a thing or a subsystem of a thing. Is the engine of my Volvo so complex it deserves its own digital twin? And it has all its properties. Some are static, some are telemetry properties where data is flowing in and real-time things are happening. And maybe it has a parent-child relationship with the entire car. And properties of the engine map to properties of the overall car. And so when there's a problem happening with some part of the engine and it bubbles up to the car, will the whole car fail? Or
the only thing that you can know that is by context. So if the digital twin on its own can't absorb its context, it's like you can't really do anything, because otherwise you're going to know more about the stuff that you already know about, sort of. But I mean, it's I think it's a good analogy.
That's
if you
why I've
sort
always
of
said
the context.
That's why I've always said that digital twins should live at the heart of every IoT platform. Because the IoT platform is plumbing, right? Let's not overthink what it is. It's just plumbing. It's sending data from the real thing, the physical twin or process or whatever, into your digital one, and it brings it to life. It hydrates that object. I always have thought about digital twin models like a base class in programming, and then the digital twin instance. Like I have a model of an XC60, and then I have 20 million instances of XC60s on the road. Exactly. And I have instance of the twin that inherits all those properties and things from the model, because you don't have to do things over and over and over again. But your IoT platform brings the whole thing to life. When you're talking about a twin at runtime, obviously there's simulation twins, where maybe you're designing, or also what's great about a twin. So when I hear talk about algorithms and AI, that's just the next step, an add-on, where it combines twin structure capabilities and data flowing and pattern matching of data. Think of it this way. You know how, all right, let's go back to physical stuff. How do we test aircraft in flight when we're testing it with a physical twin? We put it in a wind tunnel. We also do that with cars for aerodynamics. Think of digital twin simulation as putting your digital twin in a wind tunnel. You're sending fake data at your twin. Your twin is catching it.
Or emulate the digital twins and not simulated, which is then it's real-time data from the physical world. So you sort of combining that. That's the better version. And that's been the problem for autonomous driving, that they just work with simulated data, while others have data from the real world, so they they don't have to guess as much. But it's a good. I love the analogy, and I love digital twin should be at the heart of every IoT platform. I got a tattoo that somewhere. I haven't gotten a tattoo yet, but that's going to be my first one.
I'm excited about that. But you have software agents or bots, whatever you want to call them. They're sitting there. There's the twin that says, "This is what my structure of the car is." And maybe I have KPIs. Let's just keep it simple. On my tires, the tire is supposed to be at 32 PSI pressure. That's the green zone, KPIs. And then yellow, it's a little either more full or less full, and then red, right? And this is basic manufacturing threshold stuff too. Just getting back to manufacturing, which I know we're talking about. And I'm just going to stop talking because Donna has something to say.
No, I'm excited. I want to add more to it because I really liked how you described. This is what you described, the data, the car, this is what people think about digital twin. And Nicholas just kind of alluded to that. So what we do is we do digital twin of organization. So again, it's a software, it's a data. We bring in all the people in your organization. We model that. We would bring the process, we bring the policies, the systems that you're connected in, ERP, CRM, all of that. We're pulling data from it. Other type of digital twin, like that discrete, the composite digital twin, all the asset digital twins, connect them all so you can actually have a really holistic view of your organization digitally. So you really have the whole operations in a digital format. So if I decided as a big, let's say manufacturing, like a factory, and you want to change a process or you want to change operation, COVID has been a great example for that from a business continuity perspective. If you unplug something, you're going to simulate it. You're going to be able to see what would the impact be on your people, process, systems, your communication, your change management, like all of that will be taken care of in that digital twin of organization.
Yeah.
So it's just a different view of actually a virtual replica of your operation. And that's huge for like, massive operations, complexity, cost optimization, efficiency. Like, yeah.
Or maybe let me
Yeah.
bring in Ajit here, because
Yeah,
Ajit, you come in with a different perspective from the AI side of things, and I know you deal a lot with what is called model-based design. Could you explain to us how that works as far as digital twins are concerned?
Yeah, sure. Yeah. So for us, it's a word which has a broader and older context, and even in this discussion, people have been talking about it, but we have kind of used it as an umbrella term to combine a number of things. So the word, the model-based design, the concept of it is quite old, which means that you take a virtual model of something and you design it such that you combine the modeling and the automation together. So you do the different iterations when you're doing something physical that helps you to model something, test something faster, etc. Now, if you actually think about it, what is the contra of this idea? This is something which again was mentioned by Rob and possibly Dana, was the physics-based modeling, the wind tunnel type situation. Yes, so I think that what you're trying to do is do the sort of the virtual side of it instead of the wind tunnel physical side of it. And then what we then thought about was, how can this word be used to describe what we actually want to say? So we want to talk about digital twins, but we want to talk about it through the whole life cycle. And I mean by that, at least looking at the manufacturing, then you would go down to the CAD side of it, look at SolidWorks, CATIA and stuff like that, or Autodesk even, and then look at how that combines with additive manufacturing, 3D printing and AI within that. Then you take those models and you build them into the production or the product pipeline, and then you take to the AR VR side and do the massive simulation, visualization of the simulation. So this is how we sort of adapted that word, and I think that makes sense, because we wanted to call it digital twin, but we also wanted to put in the other stuff behind it, the additive manufacturing, the AR VR, and we couldn't find a word which bridged the gap except use a traditional word but use it in a different context. And that's just what my interpretation is.
Okay, yeah. If anyone wants to add to that?
I think it was great. Okay. Well, you can ask the question, and I may see if I can formulate it as a response to Ajit. But I love that as well. I love that.
Okay, all right. So while we have you then, Nicholas, I think so clearly here a digital twin system really, it consists of a lot of moving parts, and there's quite a lot of exchange of information there. So how do you ensure interoperability between the digital twin and the underlying information sources?
Such a great question. And I think, again, like, you heard Rob talk, and Ajit and Dana and me as well, but there are so many different digital twins, right? And, I've been involved in a lot of different initiatives. And one of the best questions was this sort of on the same topic as in, okay, we have a smart city digital twin. And then I had someone from the building side, and they said, okay, how does that work with the building digital twin? And then I had someone else from the mobility side, or we have a mobility digital twin. And then you have like water and everything else, right? So that is like, how can they interact? How can they exchange information from a technical perspective? But here's also what I want to go back to, what interoperability means for me. So you have like legal interoperability, you have semantic interoperability, you have, all this technical stuff, but you also have organizational interoperability, which Dane is an expert in. But then you also have, so for me, the true interoperability is, it's not just, how systems communicate. Because if you want to have the systems to communicate, again, what I said before, especially in manufacturing, you have to have the OT, IT, like the people alignment. So how do you get people to align and become interoperable, right? And for them to look at dashboards from, Azure IoT or, physics-based modeling, which is great for some, or some data science stuff, it's not necessarily like the CEO or CFO or head of, X division can understand that stuff. So for me, the true interoperability aspects, they are there. They appear when you have actor-based models in mind, where humans, systems, standards, everything operates on sort of like the same level. And I think that can only be acquired when you have digital twins that are reality based, as in they look like reality. You go in there, and this is again why I love what Ajit was saying, that if you have it in virtual reality, if you create this again like MVT style some things, where you can go in there and not the physical room that we had at JPL in 95, but a digital version of whatever reality that you're trying to do something with. You step in there and you agree on something. This could be the starting point. I think that's that is one part, to get human interoperability, so to say. And from the technical side, again, I think one of the most important things for digital twins is, the question as in, how do your platform cater to, of course, AI, machine learning, physics-based modeling, but also how does it cater to standards? Because it's not about, selecting one standard. It's impossible. It's selecting a platform that can handle any standard, because these have to be scalable. They have to be interoperable. And again, if you're looking at it, if you start with the mobility digital twin, either it has to exchange information to something else that is built upon a standard within buildings or mobility or healthcare, whatever that might be. So the exchange of standards between different domains, and again, the knowledge transfer between domains, irrespective if it's people, systems, it is so important. And I think that this question has to be asked for this twin washing, sort of like to understand, so that you don't lose the color, because otherwise it's, I've seen so many companies that are going through, data, taking these data lakes, data swamps, trying to create value. Impossible. They can't do it. There's so many.
I really like this losing the color as well. It's not only just washing, it's
washing
and losing the color. Amazing visual
it's a question,
analogies.
but it's a dynamic question. But interoperability, if Rob said, that digital twins are at the core of the IoT platform, interoperability is sort of like in the heart of the digital twin, because otherwise you're going to be, you're going to solve something really fast in a silo. You're never going to be able to scale. I think that's one of the major problems today with any sort of IoT platform or digital twin platform, the scalability aspects, and to be able to scale outside and across domains. So that's where true interoperability comes into play.
I had a painful interoperability, digital twin interoperability problem many years ago. So when we built asset avatars for Lumada, because we're living in Japanese factories at Hitachi, well, other people started getting onto the digital twin bandwagon. So another player was SAP. And after they'd done their initial IoT platform, then they came out with something new called Leonardo. And then they acquired a Norwegian company to get digital twin technology baked into Leonardo. And I spent a bunch of time in Waldorf, and SAP people spent a bunch of time in Santa Clara. And it was all about interoperability, translation between Hitachi digital twins and SAP digital twins. And it was ridiculous.
It's a horrible. But that was also like why GE and Predic's platform, they couldn't really make it happen. They're like behind the scenes. I think like we all are talking to probably the same people, trying to help the same people. So I think like behind the scenes, no, I'm not going to quote Zoolander here, but I mean like behind the scenes, the old members warehouse stuff, that's where you hear these things. There's a digital twin washing on this side, but then again, combining different data sources and getting to the physics-based modeling that can, work as actor-based models or multi-agent systems across domains is really, really difficult. You can do it in one domain quite fast, quite good. But then when it's like, okay, why is this happening with the XC60 when Rob is driving downtown? We don't know, because there's no access to the context. And then when you want to bring in context, again, that's where Rob was. We can't get it in because it's not interoperable. It's a totally different foundation of something else. So, I mean, absolutely. I mean, I can talk about this forever. Hopefully I won't, because we solved it. But until now, I hopefully, I will talk about this forever. So great question.
Solved it.
Okay, maybe if we can get specific about the standards and frameworks or even platforms. Are there any frameworks or standards that are in existence today that you'd recommend to manufacturers that want to implement digital twins?
There are no
I think it's like the digital twin platform. I think if we go to manufacturing, because we're here, you have the asset administrative shell, which is being developed, I think, in Germany. I think that's a great one. But again, it can only do as much in that different domain. And for that domain to understand what is actually going on, they have to pick up data from other domains, like Dana's domain or IoT domain or whatever that is. And you also want to run physics-based model on it. So it's again, every industry has their own standards. All of them. We have so many standards. It's unbelievable. Taxonomies, ontologies, and that is knowledge that has been created by people at some point, turned into something for systems to use. So again, like every platform needs to be able to absorb standards, whatever they're coming from, so that they can leverage them together. Because again, it's like a loop, right? So we did stuff, and then people interpret this, created these standards for system to use, and now we're trying to create these loops to AI to feed on these things, but we shouldn't, we have to absorb the reality as it is and not just, okay, first we have to change this. Okay, but that's going to take us 5 years to change the organization to what it needs to be. Can't we work with the data as is? Can't we work with the organization as is? And I think that's is that a concrete answer? Absolutely not. It depends on how you see it, right? But I think like the concrete answer is go to your domain, understand that there are different standards that have been developed over ages, to be honest, and absorb that knowledge, but also be careful. At some point, you need to absorb something else from another domain, and that's gonna, if you don't prepare for that, that's where most companies are struggling with right now. So you have Microsoft DTDL. They're trying to do this at some point, having different digital twin data languages for buildings, the Swedish one, real estate core, and then you have for energy, et cetera, et cetera. So, I mean, we understand that this is a problem, as I guess like industry experts, but it's really hard, again, with the twin washing out there, to bet on something and you're heading into a wall at some point. So, yeah, be wary, I think.
Yeah, I'd like to add, but this gets us to the open source kind of activities that is happening with digital twinning, right? Like, I mean, if you think about it, like think about industrial practices, companies will face the standardization, deadlock problem where, on the other hand, we might not have sufficient practical experience on hand to do all of this, but at the same time, you do need the practical experience, the experimentation part of it. So that's where the open source kind of work has been happening. So the open manufacturing platform, they're doing open source work, Digital Twin Consortium, the Industrial Digital Twin Association is trying to build standards and kind of specifications for industries, but also let's identify a need, let's implement a prototype, MVP, MVT, and then test and implement and kind of collaborate on it. So that's kind of where it's a whole different, a shift when it comes to digital twin and open source.
Oh, okay, interesting. Maybe for those who are still struggling with really grasping this concept of digital twins, Dana, could you provide some common use cases of digital twins, particularly in the manufacturing space?
Absolutely, yeah. So when we do look at manufacturing, we're talking about two different things, right? I mean, we're talking about the operations and how you're running your equipment, the facilities, like the business process, the supply chain. But then you do have the product that you're producing. So that's there are different use cases that really digital twin can serve. It can work for product development because now you can, test, design, test the feasibility as Rob alluded to that, right? With the car and the wind machine, you can test these things using the digital twin and focus on really building a feasible product. Another one can be design customization. This is used in other industries as well in terms of, how can you design different product and personalize them and to be able to provide different experience to customers and all of that. Another one would be floor performance improvement. So it's process improvement in terms of how you can monitor, analyze the end product and the process that gets you there and really help increase efficiency, cost reduction, and be able to really lean out your processes. So it can be used there as well. One of the main ones that it keeps, you read about a lot when you read about digital twin is predictive maintenance, right? for equipments, for downtime of machines, like, testing them. If you want to introduce a new thing to the machine, like how can you test that before you you really do it? But that's really a big use case in manufacturing, predictive maintenance, and I would say the process efficiency. Yeah, so those are kind of like big highlights on that one.
Okay, awesome. You
Go,
want to add
Nicholas.
something, Nicholas?
Nicholas has something.
Yeah. Oh my God. I got so many ideas here. No, I'll let someone else chime in. I'm working on a paint sketch here.
All right.
For those of you know me, I'm a master at paint. So, but I think it was great, great explanation by Dana.
Okay. All right. So now maybe over to you, Ajit. What I'd like to find out is, I mean, we all know that in an industrial setup, things change quite often. So you're not going to set up a digital twin and then you're done with it. So obviously a new sensor could be added or a new boiler could be added. How does the digital twin then automatically synchronize all of this information? Is there like any kind of mechanism that could be used for synchronization?
Well, this is a normal implementation and part of any digital twin. So I don't think there is a specific technology to do that. And I mentioned previously the Microsoft toolkit, which we are working with, and there are very standard ways in which you can do that. Azure IoT Edge, Azure IoT Hub, synchronization, all of those things are pretty standard. But I guess your question was not the technology. Your question was, what if something, a physical object, appears in the ecosystem, and how does that get reflected? Again, I think this is a system design problem, meaning that how do you define your system? How do you define? So there was one other term. I mean, since we are throwing so many different terminologies here, there was this term which I heard in the early part of the digital twin, which means, I guess, a few years ago, 2 or 3, was this idea of the digital shadow. And I think that this is an important idea, because what that means is that you effectively keep a backup of something. And then when the data comes back on again, when the device comes back on again, it just gets resynchronized. So I think that by definition, you need to have a shadow first before you start to do anything with it, especially in IoT. So effectively, then you have all these devices which may or may not have connectivity, and then they connect back and you connect back to them. So this is the first kind of a pull architecture. And then what happens to the data after it's virtual is your problem, how you define your application.
Okay. That's awesome. Now, Rob, it seems we're running out of time here. I just want to bring you in on this. Some time back, you published an article about using digital twins to represent employees. Could you explain to us how that works?
Yeah, I don't know if that was a good article for how HR should evolve in a company, or if it was completely dystopian and refers to some horrific future. But I think I was writing that article on a plane, actually flying over the Atlantic or something, and I was probably, anyway. But it really hit me, the idea that representing people as twins. I remember the earliest times I was thinking of it was probably back in the Lumada timeframe. It's easy for us to sit here and say, I can have a digital twin of a spaceship or a car or some machine that has electronic stuff that can send you data about its health. But what's very different is when you have to do a twin on behalf of something that's not a machine, like a person. Or, for instance, like if I'm looking at if I'm out in the farm, trying to do digital twins of a tree, an apple tree, or whatever, what am I trying to do? I'm going to infer from other things around it, its health, right? And so, like with this case, soil moisture, temperature, atmosphere, things like that, I'm inferring the health of an apple tree, for instance. With a person, I wrote this crazy article about people in a company, and it kind of started out with the idea that, hey, you know what? When you go to a company, you probably get an employee manual, maybe, that says, this is how you're supposed to do your job, generally. And you may have something specific, like your commitments and what you're supposed to do. People need help with that kind of stuff. And so I always imagined it was almost like a I don't want to say like a personal digital assistant, but it's a twin. You model a twin of that employee. So like when I talk about a digital twin model of an XC60, and then there's millions of instances, there is a model of your job. Let's say my job is I am a salesperson at whatever kind of company selling widgets. There's a model that and properties that define what that job is supposed to do. There's APIs of who I interact with in different parts of the company, coworkers, and customers. And then there's the actions you're supposed to take. And so what this was supposed to do is really a new way of looking at human resources and helping people to do the job the best way they can. A lot of times we're just like everything. When I talk about what are we competing with IoT, you're competing with somebody with a clipboard and a pen. That's the reality. And the digital twin is the exact same thing. And so it's everyone's best effort for stuff that got written down, right? And so the idea is, and Donna's talking about this a lot in a larger scale than I am with the whole organization, but you model roles in a company, and then the instance of the roles is you're going to hire, well, you might hire a human, but you may determine that's because remember, what's a job? A job is a collection of tasks to be completed, right? That's all it is. Those tasks may be completed by a human, but you may find that we've seen the rise in this robotic process automation field, RPA, happening. You may find that a digital version of whatever that job is can fulfill those tasks just as well. I know this is starting to get really weird, but if you step back and go, because we make so many assumptions about what a company is and what jobs are and what people are and everything. And if you step back away, you go, well, no, a company is a goal to sell these widgets and make money and be alive. And in order to do that, we've created a bunch of roles, and the roles, they're jobs to be done. And it's comprised of a list of tasks. I need to do these tasks in order for my little part of the job to work, to sell these widgets, or make the widgets and market the widgets, and everything like that. Step back and find out if you can make digital models of all these things and the properties there, and you may find that some of these things can be done digitally instead, especially when you have scenarios in COVID. When it started, I saw lots of companies were early on laying off lots of people. But you know what? They were reaching out and said, I still have to accomplish this list of tasks, but now I have fewer people because I didn't have money. What do I do? Everybody's always trying to find how to do more with less, right? As you know, I've been working with these farmers using IoT and twins. Guess what? They've got labor shortages. We're running out of water. We're running out of arable land. That's another scenario where people have to do more with less to feed a growing planet, right? Same kind of stuff. Anyway, it's pretty crazy, but it's an interesting thought experiment.
Scenario planning is huge, right? And that definitely COVID highlighted the importance of business continuity and how can you really use this technology to be able to do that. So definitely great use case for it. All industries.
Yeah, totally.
Yeah.
Okay, awesome. All right, I think before we take, I think we've only got one question here. Is anything that you want to add there, Nicholas?
Or... Yeah, just real quick, right? Okay. Yeah. Can I share my screen real quick? Is that okay?
Yeah, sure.
Okay. So when Dana said, she talked about, the supplier and then the factory and the product and the user, right? So that it depends on manufacturing, because the manufacturing space, and then you also have an organization. I actually missed that. So while you were talking, can you see my screen?
Sketched something.
Yeah, I had to.
God. This is awesome.
Can you see this?
Yeah.
Yes.
Okay, so like a traditional organization, right? Or like a traditional organization is up here, but you have all these, stakeholders. You have the supplier, you have the factory, you have the product, and the user. Understanding that, supply chains or whatever is going on takes usually a lot of time, and the data is like so many different silos. But again, like I think with digital twins, you can actually, you bring in the data from supplier, from the factory, from the product, the usage, as well as understanding the organization. And again, going back to, who should be there to take these decisions. And then you can, bring that into the digital twin, or let's say the IoT platform, Rob, where the digital twin lives at its heart. And then you have interactions between people from the supplier, the factory, the product, as well as the user. So they can go in there, look at the data, that is being fed to digital twin in real time to take these decisions that otherwise would take, forever for the supplier to understand, okay, what should we do better? Or for the factory, what should we do better? Because the user over here, they experience something that is not great. So they have to go back to the R&D organization, go back to the supplier, to the factory, to the product, etc. Something for me, and like an organization, works all the time, but the digital twin from a collaboration standpoint, and to make, it can fold space and time. And I just call it twin time to make Rob, happy of all this buzzword stuff.
Thanks for that.
But I think
Thank
that's
you.
like, it's freeze on freeze stages, which usually you use in management consulting anyway. But there's a difference between here that you can bring these people together, and then the curls up into the digital twin. It extends in the traditional organization. But again, once you want to make better decisions about anything, you use the digital twin as a collaboration medium or as a boundary spanning object between these different domains. And you can use that, with AI, with people, and you bring this into focus. Again, this was like 5 minutes in the making. Well, it's 20 years, but it took 5
I love
minutes.
it.
Yeah.
Nicholas,
Well
do
said,
you
well said.
do you include like Einstein's time dilation in this as well as you're approaching the speed of light?
Yeah, of course. Yeah,
Okay, good,
Yeah.
good. Okay,
it's behind the scenes.
okay. I just want to check.
Okay, so I'm just going to take this one question. While I do that, maybe you can prefer just like each of you 30 seconds parting words. So Philip says, are there any structures or pipelines that you or your organization recommend for establishing the data model, as Rob mentioned, or technical skills for a team of implementers? I don't know if it's clear. Anyone wants to take that?
Woo! You know what? We're all beginners, and it's good to be able to start somewhere. And so when you start the model first, it's a structure. You know what? You could get an Access database or an Excel spreadsheet and create a model of a thing, whatever it happens to be. That's a good starting point. What is its name? What are its attributes? What are the data types of those attributes? What is the data that's going to come flying in? That's a great place to start anything, and then from there you go on to relationships between twins and processes. But yes, start with something simple like a car.
Okay.
I would say go to the Digital Twin Consortium, look at the interoperable manufacturing digital twins, look at the roadmap on how to get started, how to get going. And this reflects exactly, I think, what Ajit said as well before. You have something, and then it's the synchronization, and then it's the algorithms that you want to apply. So we have that, I wouldn't say figured out, but we have that written down. And again, how to get started, how to get going, how to succeed with digital twins in manufacturing. There is an idea at least. And if you want to know more, join the Digital Twin Consortium.
Okay, so
Yes,
we're already over
agree.
time here. So
I would agree
go.
with that as well. I think at least I think me, Nicholas, and Dana are members of the Digital Twin Consortium, and I think that definitely an organization which is doing a lot of very cool things, and it's pretty agnostic in the sense that there are lots of companies involved. So I think that's a great place. Yeah.
Okay, awesome. Dana, any parting words?
Yeah, I was just going to comment on the skills part, because this is something kind of we didn't address a lot. But when it comes to digital twinning and adoption, we're talking about digital upskilling. We're talking about digital skills, and literacy, which is soft and technical. So for the technical part, going to Rob's point about data and analytics, so that would be a good technical skill to have. Like cloud computing is another technical skill that we need to have, as part of the skills that we need when we work with digital twin. But from a soft skills, digital soft skills, or we would look at like agility, like how are you going to prototype and like test and move forward. And it's a mindset, being an agile, and it is a mindset. So that's a whole cultural soft skill that you do want to have in your organization to make sure that you're using and adopting the technology properly. So kind of look at digital skilling from soft and technical as well, soft and hard for sure.
I'm just going to echo that with the mindset. It's so important. Engineering mindset, you want to solve problems. not just getting stuck in processes and doing the same thing that you always have done and expect different results. Get the mindset of solving problems, use modern tools, invite experts that are great at AI. I'm like Rob. I mean, I know what we need to do to cater to AI. I don't know AI really myself, but I mean, get it done, get the mindset, get started for God's sake, and run fast. Don't get stuck in paralysis analysis. And again, invite experts to help you. And if you're going to invite experts to help you, you better define the problem so that you can explain it to whoever it is in an understandable way for people and systems. But mindset is everything. Without that, yeah, good luck.
Okay, all right. It seems we're way over time. If there's any quick parting words anyone wants to mention before we close the session.
Yeah, so for me, I think the parting words again are what just to echo what Dana said is the upscaling thing. And I think that's what I think again look at in Oxford, but I guess probably with a more technical perspective. So we do not look at the more sort of the agility human perspective, much more about the how to build that. But yes, I totally agree with it's a great discussion, and I've learned a lot I've learned a few buzzwords as well, actually. But I think it's been a great discussion, and thank you, Kudzai, for this. That's great. Yeah.
If anyone is in Vegas in January, I actually have a seminar called, how to win at Buzzword Bingo. So that's why.
See you there. See you.
Okay, all right. Thank you so much. Thank you guys for taking the time to come out and share your insights.
Thank you so much.
Thank you.
Great stuff.
Thank you, everybody.
Take care.
Fantastic moderation as well.
Thank you, Kudzai. Thank you. Bye.
Okay, bye.